So taking a look at number one, the probability that you will be ticketed for illegal parking on campus is about 1/3. During the last 9 days, you have illegally parked every day and have not been ticketed. Today, on the 10th day, you decide to park illegally. Assuming the outcomes are independent from day to day, the probability that you will be caught is. So just keep in mind with the whole business of the probabilities being independent, that your probability of getting ticketed on the 10th day really has no factor or no bearing on what happened during the first 9 days. So if the probability that you'll be ticketed on any given day is 1/3, well then the probability that you will be ticketed on the 10th day is also 1/3, because what happens in those first 9 days is not going to impact what happens on the 10th day. So that's the answer for number one. For number two, this is a probability model question. And the question says, a friend has placed a large number of plastic discs in a hat and invited you to select one at random. He informs you that they have numbers on them and that one of the following is the probability model for the number on the disc you have chosen. Which one is it? So remember that for it to be a true probability model, it needs to list all possible outcomes and list the probabilities for each of those outcomes, and the sum of those probabilities has to equal 1. So the answer to this question is C, because if you add the following probabilities together here, 0.1, 0.2, 0, 0.3, and 0.4, that's the only probability model that equals 1. So if you look at this one here, if you add those together, that goes over 1. Same thing here. The values of those probabilities go over 1. The values of these probabilities here don't equal 1, and if you notice this one here, same thing, the probabilities go over 1, and if you notice you have a negative in there. Just remember, probability can never be negative. So that's the answer for number two. For number three, it's a two-way table question, and it says the two-way table below gives information on seniors and juniors at a high school, and by which means they typically get to school. So question 3 says you select one student from this group at random. What is the probability that this student takes a bus to school? So if you notice here, there's 170 students that take a bus to school out of 550. So the proportion for number 3 of students that take a bus to school would be 170 out of 550. And if you divide that out, the answer to this comes out to be B, 0.309. So that's the answer for number 3. For number 4, it says you select one student from this group at random. If the student says he is a junior, so we're just talking about the juniors in this case here, so we're just talking about this group right here, what is the probability that he walks to school? So if you notice here, there's 48 students in that group that walk to school out of a total of 300 juniors. So if you divided 48 by 300, you get approximately 0.16, and that's the answer for number 4. For number 5, the question says, select one student from this group at random. Which of the following statements is true about the events typically walks to school and a junior? So if you're looking at the choices, it's talking about mutually exclusive and independent. So if you just talk first about mutually exclusive, remember those events are mutually exclusive if it's two outcomes that cannot occur together. So these two events here, walks to school and is a junior, they are not mutually exclusive, because if you notice here, there's 48 juniors that both walk to school and are juniors. So we would say here that the events are not mutually exclusive, which means the answer has to be, in this case, B or D. And if we're talking about independence, in terms of the two variables, one depending upon the other, these events would be considered independent, because what grade you're in does not have an impact on what type of mode of transportation that you use to come to school. So just because you're a junior, that doesn't mean that it has an impact on whether you walk to school or not. So the answer to this question was B, for something like that there. So that was number 5. For number 6, this one here, it says event A occurs with a probability of 0.2, event B occurs with a probability of 0.8. If A and B are disjoint, meaning they're mutually exclusive, then what's the probability of the following? So just remember that if events are mutually exclusive, what we know is true is that the probability of A or B is equal to the probability of A plus the probability of B. So in this case, if you added the probabilities of A and B, 0.2 plus 0.8, this comes out to be positive 1, which is what choice A is there. So that's the answer for number 6. So just keep in mind that if events are mutually exclusive, then this right here has to be true. The probability of A or B equals the probability of A plus the probability of B. So that's just some different things with that there. For number 7, this one says if the probability of A is 0.24 and the probability of B is 0.52 and A and B are independent, what is the probability of A or B? So just remember the whole key note here about independence, and there's a couple different sort of things working with formulas here, is that if the events are independent, then that means that the probability of A times the probability of B is equal to the probability of A and B. So if we're talking about the formula for OR, just remember that the probability of A or B, and this is sort of the general addition formula, this doesn't have to do with what we just talked about with mutually exclusive, but this is the probability of A plus the probability of B minus the probability of A and B. So that's just the general OR formula there, general addition formula. So probability of A is 0.24, the probability of B is 0.52, and then you have the probability of A and B. Well, if the events are independent, then the probability of A and B is simply just to multiply the probability of A times the probability of B. So this would be minus 0.24 times 0.52, and when you do that, you get a value that's roughly 0.6352, which makes the answer for this C. So that was the answer for number 7. For number 8, it says people with type O negative blood are universal donors. That is, any patient can receive a transfusion of O negative blood. Only 7.2% of the American population has O negative blood. If 10 people appear at random to give blood, what is the probability that at least one of them is a universal donor? So what we know is true from this problem here is that the probability that someone has O negative blood is 0.072. So we'll just put here, has O negative. So if the probability that someone has O negative blood is 0.072, and what the question is asking here is what's the probability that at least one of the 10 is a universal donor. So just remember that if it's at least one of the 10, that means you could have 1 is a universal donor, 9 or not, 2 is a universal donor, 8 or not, 3 is a universal donor, 7 or not. And we did a question like this in one of the reviews and on one of the previous quizzes that we had. So we said that the complement of at least 1 is a universal donor is to say that none of them are universal donors. So if the probability that someone has O negative blood is 0.072, that means the probability that someone doesn't have O negative blood would be 0.9280. That's just 1 minus 0.072. So this would be 0.9280 does not have O negative blood. So when we're talking about at least 1, the complement of that would be none of the people have it. So if we found what the probability that none of the people have O negative blood, we would say that the probability for that would be all 10 people do not have it. So that would be 0.9280 times itself 10 times. So if I did this here, if I did 0.9280 to the 10th power, and this comes out to be roughly 0.4737, that's the probability that none of the people, none of the 10 people would have O negative blood. So the complement that none of them have it is at least one of them have it. So if I did 1 minus 0.4737, that would give me a probability of 0.5263, and that's the probability that at least one of them have it, which makes the answer to number 8C. For number 9, the question says, of people who died in the United States in a recent year, 86% were white, 12% were black, 2% were Asian. Diabetes caused 2.8% of deaths among whites, 4.4% among blacks, and 3.5% among Asians. the probability that a randomly chosen death was due to diabetes is about what? So if you made a tree diagram for this, right, so if we had white, 0.12, and then we had black would be, I'm sorry, white would be 0.86. Let me fix that there. 0.86. So this is 0.86. This is 0.12. And then we have Asian, which would be 0.02. Then it says, among white people, diabetes caused 2.8% of deaths among whites. So we have here, let's say, death and then no death. So this would be 0.028, and then this would be 0.972. And then for blacks, we have, once again, death, no death. And for blacks, it was 4.4% cause death. So this would be I'm getting a little tight here, 956. And then for here, we have, for Asians, this would be, let me fix that real quick. This would be 0.044 right here. .044. This would be 0.956. And then for Asians, we have 3.5%. So this would be death, no death. This would be 0.035. And then this would be 0.965. So the question says here, the probability that a randomly chosen death was due to diabetes. So that's this group here, that's this group here, and that's this group here. So if I found the probabilities for those, and I added those together, so if we had, for the top part, if we did 0.86 times 0.028, this comes out to be 0.02408. And then we have for this group here, this would be black, and diabetes caused death. This would be 0.12 times 0.044, and this would be 0.00528. And then if we added, if we put this in here, Asian and diabetes caused death, so this would be 0.02 times 0.035. This would be 0.0007, and if you found the sum of those would be 0.030. So that's the answer for number 9. For number 10, we have in your top dresser drawer, 6 blue socks, 10 gray socks, unpaired and mixed up. One dark morning, you pull 2 socks from the drawer without replacement. What is the probability that the 2 socks match? So there's 2 different ways that you can get the socks to match. You could get 2 blue socks, or you could get 2 gray socks. So if you notice here, there's 16 total socks. So if I'm going to find first the probability that I would get 2 blue socks, so when I reach in from the very beginning, my probability of getting a blue sock would be 6 over 16. And assuming that I choose a blue one on the first trial, my probability of getting blue on the second trial would be 5 out of 15. So just remember that because you're holding the blue sock in your hand, there's 1 less blue sock and there's 1 less total socks. And when you multiply that out, this comes out to be 1/8. So 1/8 is the probability that you would get 2 blue socks, or you could get 2 gray socks. So my probability, if I go back to the beginning, my probability of choosing a gray sock would be 10 out of 16. And then if I reach in again, once again, I'm holding one of the gray socks, so now my probability of getting a second gray sock would be 9 out of 15. Because once again, if there's 10 total gray socks and I'm holding one, there'd be 9 left for me to choose from, and then 1 less gray sock in the mix, and the probability for that would be 1/2. And if I take those probabilities and I add them together, since it's OR, this comes out to be 5/8, okay, which in this case, this comes out to be, that's not correct. So Let me see real quick here. So I got 6 over, check my math here, 6 over 16 times 5 over 15. Let's see here. So I got 6 over 16. I'm going to pull my calculator up on this one. So when I do this here, I'm going to get my fraction key up with this. So I got 6 over 16 times, fraction key again, this would be times, nope, let's try this again. So I got 6 over 16 times 5 over 15. So this would be 5 over 15. So that's one possibility. So I could get 2 blues, or, so I'm going to put a plus in there since it's or I could get 2 gray socks. So this would be 10 over 16 times this would be 9 over 15. When I multiply this together, I get positive 1/2, which makes the answer to this one D. So that's right here. So that was the answer for number 10. So that was the multiple choice questions. The short answer questions, number 11 says, many fire stations handle emergency calls for medical assistance as well as those requesting firefighting equipment. A particular station says that the probability that an incoming call is for medical assistance is 0.81. This can be expressed as the probability call is for medical assistance at 0.81. Assume each call is independent of other calls, and that'll be key for what we're going to do with the answer to part B. So part A says, describe what the law of large numbers says in the context of this problem. So the law of large numbers basically says is that as the number of calls increases, so as we get more and more calls, the proportion or the probability of calls for medical assistance will start to get closer to 0.81. So just remember, when you're describing the law of large numbers, you want to say that as you do something repeatedly, as the number of trials of something increases, that the probability or the proportion will get close to what in theory it's supposed to be. So that was part A. For part B, what is the probability that none of the next 4 calls are for medical assistance? Well, if 0.81 is the probability that they get a call for medical assistance, then the probability that they don't get a call for medical assistance would be 0.19. This would be no medical assistance. So that means it's a call for something else. So when we say what is the probability that none of the next 4 calls are for medical assistance, just remember the note here. Assume each call is independent of each other. So the probability that the first call would not be for medical assistance is 0.19. The probability that the second call would not be for medical assistance is 0.19. The probability that the third call would not be for medical assistance is 0.19. And the probability that the fourth call would not be for medical assistance is 0.19. So what I'm doing here is I'm multiplying to find what the probability that all 4 calls would not be for medical assistance, and the value of this is 0.0013. And that's the answer for part B. For part C, it says you want to estimate the probability that exactly 3 of the next 4 calls are for medical assistance. Describe the design of a simulation to estimate this probability. Explain clearly how you will use the partial table of random digits below to carry out your simulation. So if the probability that a call will be for medical assistance is 0.81, what we're going to do first here is assign numbers. So we'll assign 01 to 81 as a call for medical assistance, and then the rest of the numbers, 0.82 to 00, 00 being 100, would be a call that's not for medical assistance. Then I'm going to choose 4 2-digit numbers from the table, And then when I do that, I'm going to determine how many of those 4 calls were for medical assistance. Then I'm going to repeat this many times, and then the proportion of the trials that result in 3 calls being for medical assistance would be the probability estimate. So you want to make sure that you mention that you're assigning numbers, what type of numbers you're going to choose, what it is that you're going to measure when you choose those numbers, that you're going to do something over and over and over again, and that by doing that, that's going to create the estimate. So you want to make sure you mention those 5 things for a question like this here. And then for part D, it asks you to carry out your trials. So trial number 1, I'm going to choose 4 2-digit numbers. So I'm going to start on line 177, and I'm going to choose 70, 34, 87, and 28. So the number 70, that would be, yes, that would be a call for medical assistance. So we'll put a check mark if it is. 34 would be a call for medical assistance. 87, that would not be a call for medical assistance. And then 28, that would be a call for medical assistance. So here's a trial. This is trial number 1, where we got 3 out of the 4 calls were for medical assistance. So I'm just kind of making a note there that 3 of these calls, just put a 3 at the bottom of this. So out of that trial, 3 of the calls were for medical assistance. For trial number 2, I'm going to choose the numbers 71, 63, 41, and 95. So 71, that would be a call for medical assistance. 63 would be a call for medical assistance. 41 would be a call for medical assistance. 95 would not. So there's another trial where 3 of the 4 were for medical assistance. So trial number 3, I have 73, 63, 29, and 68. So 73 would be a call for medical assistance, 63 would be a call for medical assistance, 29 would be a call for medical assistance, and so would 68. So in this case, all 4 of them came out to be calls for medical assistance. For trial number 4, I have 54, 30, 90, and 18. So 54 would be a call for medical assistance, 30 would be a call for medical assistance, 90 would not, and 18 would be a call for medical assistance. So in that group there, 3 of the calls were for medical assistance. And then for trial number 5, I would have 76, 33, 17, and 14. So with this one here, 76, that would be a call for medical assistance. 33 would be a call for medical assistance. 17 would be a call for medical assistance. And 14 would be as well. So in that trial, 4 of the calls were for medical assistance. So in terms of a probability estimation, out of the 5 trials, there were 1, 2, 3 of the trials where exactly 3 of the calls were for medical assistance. So our probability estimate for this would be 3 out of 5. 3 out of the 5 trials resulted in 3 calls that were for medical assistance. So that's the answer for part D. For number 12, it says Meadowbrook School surveys the families of its students and determines the following. If a family is chosen at random, the probability that they own a dog is 0.38, the probability that they own a cat is 0.23, and the probability they own a dog and a cat is 0.12. So part A says to randomly chosen family owns a dog. C is the randomly chosen family owns a cat. Sketch a Venn diagram or a two-way table that summarizes the probability. So if we did a Venn diagram, and I'll do sort of both of these with you here. Let me make that a little bit bigger. So if I have something like this, so here's the Venn diagram. So let's say this side is the dog side, this side is the cat side. So the probability they own both is 0.12, that goes here. And then the probability that they own a dog is 0.38. So this whole circle has to equal 0.38. So if this part here equals 0.12, that means this part here has got to be 0.26. So that goes there. And then for the cats, the probability that someone owns a cat's 0.23. So this whole circle's got to equal 0.23. So if this is 0.12, that means that this is 0.11. And then keep in mind you have the people that don't own either one. So if you add the total of 0.26, 0.12, and 0.11, that comes out to be 0.49, which means the probability that someone doesn't own a cat or a dog is 0.51. So that's what the Venn diagram looks like for this. If you did a two-way table, you would have the probability someone owns a dog, and we would say yes or no for that. And then you have someone owns a cat, and we'd have yes or no for that. So when it says that 38% of people own a dog, so I'm just going to kind of draw my lines here for this. So this would be 0.38 here, and then 23% of people own a cat, that goes here, 0.23, and then you have the 12% that own both, so that goes here. So I got to fill that in first. Well, if 38% of people own a dog, that means that 62% do not, so that would go here. And then if 23% own a cat, that means that 77% do not. So as I kind of go through this here, if the total of this column here has got to be 0.38, that means this has got to be 0.26. And then over here you have 0.12 plus something is 0.23. Here's 0.11. And then if you go sort of down the column here, 0.11 plus this is 0.62. That makes this 0.51. So if you did a two-way table, that's kind of what it would look like there. So now that we have the diagrams, now we can start answering some questions. So part A says the probability that a randomly selected family owns a dog or a cat. So a dog or a cat, if you're looking at the Venn diagram, a dog or a cat would be adding the values that are in the circle here, 0.26 plus 0.12 plus 0.11. That comes out to be 0.49. If you're looking at the two-way table, the probability that someone owns a dog or a cat, so that would be the probability that someone owns a cat, 0.23, plus the probability they own a dog, 0.38, minus the probability of both, which would be 0.12, which also comes out to be 0.49. So that's just some different things with those ones there. For part 2, the probability that a randomly selected family owns a dog or doesn't own a cat. So if you go to the Venn diagram, the probability that someone doesn't own a dog, the probability that someone owns a dog or doesn't own a cat. So here's all the people that own a dog, 0.38. And then you have the people that don't own a cat, okay, which would be the people that own a dog or neither one, which would be 0.51. So if we added 0.38 plus 0.51, so that would be this group here and this group here. Here's all the people that don't own a cat. The probability for that is 0.89. If we take a look at the two-way table, the probability that someone owns a dog is 0.38. The probability that someone doesn't own a cat is 0.77. And then the probability of both of those is 0.26. So if I added 0.77 plus 0.38 minus 0.26, that also comes out to be 0.89. So that was what number 2 was showing. And then for part 3, the probability that a randomly selected family doesn't own a dog and doesn't own a cat. So if I come back to the diagram, the Venn diagram, that's this group right here. It's the group of people that are not in the circle, so that's 0.51. If you're talking about the two-way table, it's no and no. Well, this is the group right here that's no and no. Okay, and if you notice there, once again, the answer is 0.51. So that was the third part for number 12. And then for number 13, what we have is a tree diagram problem. So the question says, suppose your school is in the midst of a flu epidemic. The probability that a randomly selected student has the flu is 0.35, and the probability that a student who has the flu also has a fever is 0.90. But there are other illnesses making the rounds, and the probability that a student who doesn't have the flu does have a fever as a result of some other ailment is 0.12. Suppose a student walks into the nurse's office with a high fever. What is the probability that she has the flu? So I'm going to start my tree diagram with this. I'm going to start with has the flu, doesn't have the flu. So the probability that someone has the flu is 0.35, which means the probability that they don't have the flu is 0.65. So you got that there. Then we have high fever versus no high fever. So we have high fever and then no high fever. And then the same thing here. High fever, no high fever. So the probability that someone that has someone that has the flu also has a high fever is 0.9, which means that the probability that they don't have a high fever is 0.1. And then for the people that don't have the flu, the probability that someone has a high fever is 0.12, which means the probability that they don't have a high fever is 0.88. So if I do my multiplying for these, I have the probability that someone has the flu and has a high fever, 0.35 times 0.9. This is 0.315. And then the probability that someone has the flu but doesn't have a high fever is 0.035 if I multiply those together. 0.35 times 0.1. Then you have the group of people that don't have the flu but have a high fever. That would be 0.65 times 0.12, and this is 0.078. And then you have the probability that someone doesn't have the flu and doesn't have a high fever, so that would be 0.65 times 0.88, and that comes out to be 0.572. So now that I have this diagram, now I can start answering what the question is asking. So the question says, suppose a student walks into the nurse's office with a high fever. So that's this group right here, high fever. That's what goes on the bottom of the fraction, 0.315 plus 0.078. So out of that group, what's the probability that someone has the flu? So out of these two values here, the one that represents somebody that has the flu is this one right here. So that's what goes on top here, 0.315. So the answer to this, when you work this out, is 0.802. And that's the answer for number 13. So that's a good look at a tree diagram type question with that there.